Since I know everyone in here is paying attention right now, class. I gotta what up? It's supposed to be a yes. Miguel, where's my yes?
Huh?
Did I get a yes?
No.
That's weak soup. Weak sauce right there. All right, what page are we on in the notebook? 33. So, notebook check is probably going to happen right after this one here. But, you ain't heard from me. I ain't one to gossip saying that notebook check is going to be happening. Combinatorics. Combination of items occur when the item selected from the same group. No item is used more than once. The order makes no difference. The order makes no difference. So instead of actually, you guys actually play, anyone actually play like youth soccer, right?
What?
Youth soccer? Yeah, okay, so now, this is order makes no difference because at the end of the year, everyone got a trophy, right? Mm-hmm. It didn't matter, everyone got a trophy. That's what that is. A permutation order matters. So that team that won all their games, guess what? They're the one that get the first place trophy. Order matters on permutation. On combination, order does not matter. Everyone gets a trophy. Do you want a trophy? Yeah.
I already got a few.
Yeah, he's got all kinds of participation. So, permutation problems involve situation where order matters. Combination problems involve situation in which that the order of items make no difference. So let's look at this one. Determine which involve permutations and which involve combinations. 6 students running for student government, president, vice president, and treasurer. The student with the greatest number of votes is president. Second highest voter gets vice president, and student who gets the third largest votes will be treasurer. How many different outcomes? Now, question here. Does order matter?
Yes.
Why?
Because the first person gets something different.
Yeah, they get something different, right? Mm-hmm. And so order does matter, doesn't it? Okay, so if order matters, what did I say that one is? That was a permutation. Combinations, order don't matter. So this is a permutation. How many people are in this problem?
6. My bad.
There's 6, very good, 6. And how many am I choosing? 3. So you guys remember this from last week, right? We wrote it out like this. My permutation, so we do it in math. So my formula is going to be, what's on top?
6.
So it's going to be 6 factorial over
6 minus 3.
6 minus 3.
Factorial.
Yeah. Parentheses like that, right? Parentheses matter, especially when you're putting it in the calculator. And I know everyone's putting in the numworks right now, right? There you go. 120. Is that pretty easy?
Yeah.
Okay. So you're going to have to read through and actually decide, is it a permutation or combination? Next one. 6 people are on the board of supervisors for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees could be formed from 6 people? Now, we're going to pick how many people? 3 of them, right? Does order matter?
No.
Order doesn't matter as long as those 3 people are picked, right? Doesn't matter what order, it's just those 3 are on the committee. So this is going to be a combination. How many is in the total group?
6.
There's 6, and I'm picking how many?
3.
So it's going to look like this. So this one is a combination, but my slides are kind of out of order. Slides are kind of out of order. So we're going to flip over to slide 7. So here's the formula for combination. Formula for combination. So we said that's going to be 6C3. So 6 factorial over 6 minus 3 close factorial times 3 factorial.
Would it be 20?
Mm-hmm. Did you put it in the calculator already?
Yeah.
And for those people that want to use the calculator, you know the calculator also has a mode for this, right? So let's take a look at the calculator here. And I'll show you how to get here first. So from my calculator, I'm going to go toolbox. Gnome. Uh-huh. All right. You on NumWorks? Okay. So, toolbox. Scroll down to probability. And I know we're writing down these steps, right? That's important. So probability. Why you no work? There you go. And then combinatorics. And then there it is. So there's combination. This one's permutation. So combination is this top one. Permutation is the second one right here. So combination. 6, 3. There you go. Is that pretty easy there? All right, so going back to the notes, back up one page right there. It says comparing combinations and permutations. Given A, B, C, D, compare how many permutations, how many combinations are possible. We choose 3 letters at a time. So, I'm starting with, I have how many letters?
4.
I have 4 letters, right? I have 4 letters. My permutation, and how many am I choosing? 3. Yeah. 24. And now for this one, this is listing out all the different permutations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There's 24 different permutations of this set right here. And there is a way to go through and list them all. You will have to do that, but we're not doing that yet. We're going to save that one for Wednesday. So some of the other problems get a little bit more complicated, where we have to go through and list them all, but we're not doing it today. So I want you guys to be able to do the homework with just the easy questions. So you guys are going to knock out all the easy questions. Once you get to the harder questions that you can't just put in the calculator, then hold off on that. We'll pick up that on Wednesday when I show you guys how to do all the rest of this. Make sense? All right, make sure you guys all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff for the merch store. Okay? There's going to be a promo code coming up here soon. Anyway, and if you're done with everything, work on the homework. The old homework.